All right. Very good morning to all the ladies and
This
gentlemen.
room has
Attention,
the more
please.
hard stuff.
I'm sure everybody settled down. Yeah.
All the
So before we
easy
start,
things
just
are
to
happening
inform you all
there.
that please make sure that you keep your phone on silent mode to avoid the interruption. Yes, ladies and gentlemen, a warm welcome to all the ladies and gentlemen out here at Cypher 2016, Day 2, Analytics India Summit 2016. Well, ladies and gentlemen, before we start, little of introduction about me. My name is Parveen and I'm going to be the host for the next few hours. Well, ladies and gentlemen, we're going to have 5 sessions in total, and I'm sure you have read the agenda. We're going to have 5 topics to cover today. The very first one is going to be the mathematics and technology behind blockchain and crypto corporation. The second topic is going to be logistic regression, power and practical utility. The third is going to be practical natural language understanding from data to intent. The next one is going to be demystifying artificial intelligence, and last but not the least, we're going to have how does it my classification of algorithm going to happen. So these are going to be the 5 topics of the day. To start off with, we're going to have the very first speaker, Mr. Prithwis Mukerjee. Yes, ladies and gentlemen, the topic what he's going to cover is the mathematics and technology behind blockchain and crypto corporation. Mr. Prithwis Mukerjee is the Program Director, Business Analytics at Praxis Business School. Prithwis Mukerjee has been a footnote in the great Indian software story and was worked in Tata Steel, Tata IBM, Price Waterhouse Coopers, and again IBM doing. Yes, ladies and gentlemen, in the process of learning all that will be done with the around the software business in India and the world, from in-house software development through experimenting the new technology, management consulting, and global delivery of software services to corporate. Well, ladies and gentlemen, with this information, let's call upon the very first speaker of the day. With a huge round of applause, Mr. Prithwis Mukerjee.
Thank you, Parveen, for the introduction, and good morning to all of you. Today's, as somebody was saying just now, the topics presented in this room seem to be somehow the tough subjects. All mathematics, algorithms, the stuff. A lot of PPTs floating around in the other rooms, but here people have to really watch through everything and try to figure out things a little bit more. To make life easier for you, I would request you to not try to write down things from the slide deck, because I will give you the link from where you can get the full slide yourself. So feel free to make notes or whatever. You don't have to frantically scribble down things, what's appearing, because there's a lot of dense stuff going to be spoken about today. This is not easy stuff, it's dense stuff. You may not get everything in the first shot, because I have spent time on it. You are seeing it for about 20 seconds. Okay. So, you can always download it and at your leisure, read through it, it will be useful later on. Okay. So, with that brief introduction, let me talk about one of the very interesting things happening today. This Bitcoin stuff, we all heard, cryptocurrency. Every newspaper talks about this cryptocurrency nowadays. Okay. And thousands of them, but how does this damn thing work? It's a very confusing thing. I mean, once you get the hang of it, you will know it's quite logical and simple. But to begin with, it looks like some kind of a fraudulent scam, like a Ponzi scheme. It's not. Okay, it's not. Believe me, it's not. So let me start. How does this whole crypto thing actually work? That's the talk of my day today. Okay. But before that, let's imagine a company. Okay. Forget bitcoins. Just think of a company that offers customers a way to track their assets and transfer them to others. Banks, it tracks your money, it sends you somewhere else. And on the basis of validated instruction, which means they don't transfer it arbitrarily. You give a check or an instruction, then it transfers it. Fair enough. Now what happens is, suppose this bank, strange bank, it hires employees to do this job, this validation and checking and everything for it. but does not pay them salaries. It only pays them in terms of what we refer to as sweat equity, as equity. So, the equity of the bank is given to the employee as payment for services, number 2. And such a company has been working since 2009, okay, without any interruption. No failures has happened, nothing has happened, it is going on. And today the shares of this company are valued at a whopping $9 billion. Okay. Now, this is a company, think of it, it sounds like a very logical company. There was nothing amazing about this company. There are many banks which have a $9 billion market cap and does all this thing, except that sweat equity portion. It does not pay salaries, it pays equity. Okay. Now, imagine if this company had no human managers, no board of directors, no CEO, no managing director, no managers. Okay. If you think this is strange, it is strange, and that is exactly what is Bitcoin. That is exactly what is Bitcoin, because the whole of Bitcoin is based on something known as smart contracts. Okay. We will talk of smart contracts in great detail a little bit later. But the magic of Satoshi Nakamoto was he got the equality, the equivalence between validating contracts and rewarding it, and using the reward as the equity in the company. And for this, I think Satoshi Nakamoto, whom we do not know who the person is, it is an unknown pseudonym, he should be given the Nobel Prize not in computer science, not in technology, but in economics, because it is an amazing economic artifact which he has created. So, if there was a way of giving an anonymous Nobel Prize in economics, it should be going to this fellow called Satoshi Nakamoto or whoever he is, because he has crafted this whole story together in an amazing manner, and it has been running for the last 7 years and created a $9 billion organization called Bitcoin. Its shares or Bitcoin is actually worth $9 billion in real cash. It is not funny money. Okay. So, now let us see, this has now been called the cryptocurrency or Bitcoin. Okay. Let us see how this thing works. There are various ways of looking at Bitcoin. Some prefer to view it as a currency. Okay. It is a new way to pay for goods and services, and that is what is the common perception. In many jurisdictions, it is not viewed as a currency, it is viewed as a commodity, okay? Something like gold or say oil seeds or petroleum. Okay? So, it is not a currency in the sense of a currency exchange, but it is supposed to be a commodity. Whatever it is, it can be used as either, but I think a smarter way of looking at it or a newer way is called the Digital Autonomous Corporation. Okay? It is called the DAO or DAC. Okay? The Digital Autonomous Corporation is perhaps its true nature, of which one view it as a currency and another view it as a commodity. Okay? So, this is the story of this strange animal called the Digital Autonomous Corporation, and let us see how this actually works out. To understand this, we need to go back a little and look at the basics of cryptography. It is based on pure mathematics of cryptography. The whole thing works on that, and that is why this might be a little dense, but please watch it and look at it later on, and you will understand how this whole thing works. So, what is cryptography? Cryptography is a mathematical technique by which information in the form of text files is changed into another form, strings. We have a file, text file, it is converted into another long text string and with some logic around it. Okay? That is basically where cryptography starts. And we have various cryptographic functions which are possible. Okay? You can define a cryptographic function as the square of another number. I give you 2, you give me 4. I can give you a cryptographic function as a +2. You give me 2, I give you 4. You give me 10, I give you 12. These are very trivial, but in a sense they are all cryptographic functions. You could also work with cryptographic functions that work on text. For example, my name, it can be encrypted as some funny function I give, it will become like that, Prithwis becomes this. There can be any way you can define a transformation or some kind of a function which converts an input into an output, and there is some rules, and you specify the rules that you would like to use. Now, all those cryptographic functions are one way, they go from one side to the other, from the input to the output, rarely the other way. Okay. So, for example, you can take the sum of digits, you get 8, but trouble is the sum of digits is a collision, which means multiple inputs can lead to the same output, which is not very comfortable. Well, you can say something like a PAN number is a one-way cryptographic function, because it converts my name into a PAN number. But all that is troublesome. The best or most widely used cryptographic function is something called SHA-256. It's a very, very complicated function, I do not want to go into it, but you give it any text string, any string of alphanumeric string, it will convert it into a 256 characters. Okay. And the beauty of it is the chance of two inputs reaching the same output is lesser than we being hit by a meteorite right now. It is not impossible, after all there is nothing called zero probability, but the probability of a collision is lower than the probability of a meteorite hitting this building at this moment. Okay. So, we are safe. Okay. So, that is the SHA-256 cryptographic function, takes a number, converts it. So, you give it a function, it will give it